This is 4-6 number 9. Just going to go back through it. Again, this one you're set up with A being 2, 2, 9, 1, -1, 3, -1, -1, -4. Okay, so on this one you're going to just set these up as the minus the lambda coming straight down. Everything else you're going to be minus and 0. So when I do that, you're going to end up getting this matrices right here. Okay. Now what you're doing at this point is you want to find what the determinant of this is. Again, you could go across, you could go down, you could go down any of these rows. I decided to go down this one here, which gave me 2 minus lambda, left me with this. And again, I have to subtract 1 because this changes sign. This goes from plus minus to plus. Okay, so -1, and I put the -1 in here to solve this. Alright, again, I highly recommend use calculators to do this. That program I wrote is going to solve, it's going to factor or FOIL these very quickly, and it's going to make sure you don't make any sign mistakes, because you make sign mistakes, this whole thing just is a mess. Alright, well, at the end you're going to end up getting this. At this point, since you have a negative here, go ahead and multiply everything by negative, and you're going to get this one. At this point, a recommendation to save time and graph this as y1 is x cubed plus 3x squared plus 4x plus 2. Find out where it crosses the x-axis. You will find it very quickly. And then it crosses at -1. Again, all I did at this point is I used synthetic division. I put the -1 in, ran this back through with the coefficients, and I ended up getting what was left over was this, which left me with this quadratic. Alright. With that quadratic, I went to the quadratic equation and solved, and I got -1 plus or minus I. Alright, now when this is where it kind of gets nasty, you go back to the original and you subtract this value here. I did -1 plus I times identity matrices. And again, I always put the plus in here and just change the signs of these to reflect the minus. I ran that. And that's going to give me 3 minus I, 2, 9, 1, minus I, 3, minus 1, minus 1, minus 3, minus I. Okay. Show you how I solved that. Alright. Again, this is where it's so easy to make a freaking mistake. So set this up. But what you're going to do with this is you're going to do row operations to solve this. You want to try to turn this into 1, 0, 0, 0, 1, 0, 0, 0, 1. And you can put the zeros out here if you want, 0, 0, 0. You can do them all together if you like. I left them off, but it makes no difference. Alright, the first thing I did was I switched rows around. So I brought this row here up to here. I brought this row down to the bottom. That gave me this matrices here. Alright, at that point, what I did was I added row, because my objective now is I'm going to work down. I'm going to start with a 1. I'm going to go 0, 0. So I added row 1 to row 2 and replace row 2. That's going to leave me with this matrices here. I'll go ahead and put lines around that. Alright, my next step is I want to get this to be a 0. So I multiplied -3 minus I, put this all in parentheses, times row 1 plus row 3, and replace row 3. Okay, when I did that, I got 1, 0, 0, negative I, -1 minus I, 3I plus 3, 3, a minus I, and a 3I. Alright, what you should do now, this is kind of tricky, is you need to get this to be 1. That's your next objective. So what I did is I divided everything in this row by -1 minus I. Now, obviously this is going to give you a 1 immediately. When you have this and you take minus I divided by 1 minus I, like I did here, you want to multiply the top and bottom by the conjugate of this, which is -1 plus I. When you do, that's going to give you I plus 1 over 2. Alright, so I put that back into the matrix. So now I got this row operation. Okay, now what your objective is, you want to get this to be a 0 and you want to get this to be a 0. I chose to go ahead and do this row first. So I multiplied -3i plus 3 here times row 2, add it to row 3, and replace row 3. When I did, that gave me down here at the bottom, you notice everything's going to cancel. It gives me a 0, 0, 0. Alright, so my next step is I want to get this to be a 0. So I multiplied row 2 by I and add it to this row and replace this row. Okay, and then when I do that, I think I flip this over, and what you're going to get is, I'll go ahead and put this. Alright, so what I end up getting is I got this and this. So I can basically say that x1 is going to be a minus 5 halves minus 1/2 I of x3. And from this one, I can say x2 is going to be a minus I minus 1 over 2 times x3, because all I'm doing is moving these to the other side. And I can say x3 is equal to x3. Alright, so there's nothing that says I can't write this solution as x2 being what these values are. Okay, the problem is, one thing I want to do is get rid of the fractions. So I'm going to multiply everything by just -2. You could multiply everything by 2, actually. It wouldn't make any difference here. So when I multiply everything by -2, that's going to be 5 plus I, gives me an I plus 1, and then it gives me -2, which is my solution. Now, you don't want to waste the time going back through and running the other one, since the other one is identical except for the minus signs. So x3 would be 5 minus I, 1 minus I, and minus 2. Right, the only thing I did leave off was, let's see here, I want to go back to, oh, I know what I want to go back to. Okay, when I left off here, and you can run this through the calculator too. When you got the lambda minus 1, then what you'd want to do here is go back to this one here, and you want to run it through where you take a minus a minus 1 times identity. Again, that one you're gonna get a lot cleaner matrices. Just go ahead and run that through the calculator and determine the determinant, and that'll give your other solution. Alright, so that's, again, just a quick little video on how to solve 4/6. That was number 9. Alright?